Dear students, in this lecture we will discuss alkali metals, their electronic configuration, characteristic properties, and how alkali metals occur. What are s block elements? These are the elements in which distinguishing electrons, valence electrons, enter in S subshell are called s block elements. The alkali and alkaline earth metals belong to s block because their distinguishing or valence shell electrons enter in S subshell. For example, the electronic configuration of lithium atomic number 3 is 1s2, 2s1. So the distinguishing electrons are 2s1. It means the electrons enter in S subshell, so the element belongs to S block, and such elements which have distinguishing electrons in S subshell are called S block elements. Now the alkali metals, the elements of group first A, such as lithium, sodium, potassium, rubidium, cesium, and francium, are called alkali metals. This name is taken from the fact that oxides and hydroxides of these elements are alkaline in nature. The alkali metals, along with their electronic configuration, are: draw the Ahbab principle. You can see the Ahbab principle drawn here on right hand side. 1, 2, 3, 4, 5, 6, 7. All these S, then 2, 3, 4, 5, 6, 7. These are the P subshell. This D subshell, F subshell. Now move from here. 1s, then 2s, then 2p 3s, 3p 4s, 3d 4p 5s, 4d 5p 6s. The same pattern is to be followed because these subshells are arranged in order of increasing energies, and the filling of electron in subshells is done on the basis of increasing energies. Let us check the first one, lithium atomic number 3. The configuration is 1s2, 2s1. This 1s2 is the electronic configuration of helium. So in short form it can be written as helium. This helium means, helium core means 1s2 electronic configuration, and the remaining is 2s1. Now write the 2s1. 11. The configuration will complete as 3s1. Potassium complete at 4s1. Rubidium complete at 5s1. Cesium at 6s1. And francium, the configuration completes at 7s1. Now check the short form with noble gas cores: helium 2s1 for lithium, neon 3s1 for sodium, argon 4s1 for potassium, krypton 5s1 for rubidium, xenon 6s1 for cesium, and radon means 86 electrons are present in this bracket, and 7s1. Now write the configuration according to Ahbab principle. Let's check. For francium, 1s, check at the Ahbab principle, 1s, then 2s, 2p, here 2s, 2p, then 3s, this 3s, then 3p, 4s, 3p, 4s, 3d, and so on up to 7s1. The number of electrons in francium are 87, and this arrangement shows that electrons are here also the 87. Now form the shells. How shells are made? This is principal quantum number 1. this number, this number, this number. So write 1s2 first, then 2 2s2 2p2 second shell, 3s 3p 3d together third shell, 4s 4p 4d 4f here all the subshells with principal quantum number 4, 4 shell, 4, 4, 4, 4. And next the fifth shell, 5s2, 5p6, 5d10, and 6s2, 6p6, and last one is 7s1. Now, if you write this electronic configuration, all the configurations of the elements can be written. How? Now, go back to cesium. Cesium has atomic number 55. Configuration completes at 6s1. Now delete this area and go to 6s1. It means this area must be deleted, this area, and 6s1 should be written to write the electronic configuration of cesium. Now rubidium, completion at 5s1. Delete this area and go up to 5s1. Then potassium 19, go to 4s1. Delete this area and go to 4s1. This one is 4s1 and go back. Now 3s1, delete this area and go 3s1, and the first one is simple one. So it means if we write the electronic configuration of francium, all the electronic configurations of alkali metals can be written easily and their shells can be made also. Now the general characteristics of alkali metals. In first A, if we move downward from top to bottom, then these things increase, these properties increase, these qualities increase, these features increase, and these decrease. What are increased? Atomic number down the group increase, shells, atomic radii, ionic radii, density, metallic character, electropositivity, ease to form positive ion, reducing power, property to reduce others, self-oxidized, reactivity increase, and softness increase. It means these points are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 10 points, 10 qualities, 10 features which increase down the group in alkali metals. Now, what are the properties which decrease? Electronegativity, ionization energy, electron affinity, melting point, boiling point, hardness, heat of ionization, because the charge density of ions decrease down the group, and charge density of the ion also decrease. Charge to size ratio is called charge density decrease. Now special features, alkali metal have one electron in their valence shell. Alkali metal form unipositive ion M plus only because their first ionization energies are low. All form ionic compound and show +1 oxidation state in their compounds. These are the characteristic properties of alkali metals. Now, how alkali metals occur in nature? Alkali metals are highly reactive elements, so never found free in nature. They always occur in combined state in the form of minerals and ores. All ores are minerals, but all minerals are not ores. Ore is a mineral from which a metal can be extracted economically. It means from ore, the metal or important element which is under consideration can be extracted easily at low cost. It means all the minerals are not ores, but all ores are minerals. How alkali metal occur? Lithium, the most important mineral, is spodumene with the composition lithium aluminium silicate. Here in brackets, the actual compounds are mentioned, and these compounds contain lithium silicate and aluminum silicate. How many lithium are there? 2. And how many aluminum are 2? How many silicates are 4? Divide all the numbers by 2. So the result is lithium 1, aluminium 1, and silicate 2. Sodium rock salt, that is halide, very simple, sodium chloride, chili saltpeter, sodium nitrate, NaNO3. Natron, sodium carbonate H2O, Trona, sodium carbonate to NaSCO3 dot 2H2O, borax, Na2B407 dot NH2O. For potassium, potassium occurs as carnallite, sylvite, alunite minerals, and the composition of carnallite is potassium chloride dot magnesium chloride dot 6H2O. The placing dot is compulsory. Sylvite KCl, potassium chloride, alunite, potassium sulfate dot Al2SO4 thrice dot 4AlOH thrice. Thanks for attention.